everyone. So today we are going to do a teaching video for assignment 2 for subject SMN3013 of that. So my name is SYAKIRAH binti ISMAIL. You can call me Teacher IZZAH.
And my name is FAHMI bin ROSHIDI. You can call me Teacher Rizal.
Hi, my name is FARADYNA Shafeena binti EFFENDY, and you can call me Teacher Farah.
Hi, my name is Marina binti Muhammad RONAIDI. You can call me Teacher Marina.
So let's get started. We're going to start with Sir Rizal.
Okay, thank you. So Assalamualaikum and a very good morning I wish to all of you. Okay, as you know, I am Teacher Rizal here. So before we start, I think it's better we recite our dua first, Al-Fatiha. Amin, amin, rabbal alamin. Okay, guys, so are you guys ready? Yeah? No? Yes. Okay, so I want to recap first before we start our today class session. Before we start our topic, I want to refresh back your mind about the basic rule of integration. So in this kind of the topic, I want to ask you, what is integration? Do you have any clue or do you know anything about integration?
Antiderivative.
Antiderivative, yeah, I heard that. Who is it?
Amila.
Amila, okay, good. So is this about the process of finding antiderivative? So you have to remember about the definition of integration. So we move to the rule 1. So in this kind of topic, we have about 4 rules, and the first rule is integrate KDS. So what will it be? Anyone can answer this? Can anyone answer?
KX plus C.
Yes, KS plus C, good. Who's it? Nisa, right? I know Nisa?
Yes.
Yes, okay, good. So why we have to put C there? Anyone can? No? Okay, never mind. So actually we have to add C here, and C is a constant. It is a constant because when we integrate, we can't identify the exact constant terms. So because of that, we simply just add C to represent the constant term. Okay? Okay, next. This is the second rule. Integrate K, F, X, dx. What will it be? Another percent. Adawiyah or Hazim? Any idea? Integrate?
Factor out the K.
Okay, so we take the K and we integrate the function of fx. So we plus with C. Don't forget it. Okay, this is a special formula for integration for 1 over x. So if we integrate 1 over x, don't forget that we will going to be get ln x plus c. Okay, and for this one, 1 over ax plus b, also we got the ln, and this is the form. If you found the questions form like this, 1 over a ln x plus c. So the integration must include the constant. So I think that's all from me, and you already remember and memorize back about all the basic rule of integration. So I just want to explain about the end of the lesson for the topic integration of trigonometric function. After the lesson, I hope that you guys will be able to learn about the integration of method for cos AX, sin AX, secant square AX, cosec square AX, secant AX, tangent AX, and the cosec AX, cot AX. So I hope you guys can focus, and yeah, thank you and good luck.
This slide?
Okay, yeah.
Okay, yes. All right. Okay, so I'm going to start the next lesson. Okay. Everyone still with me? Okay, are you ready to learn more about trigonometric functions?
Yes.
Okay, now this part, okay, Teacher Rizal has explained, has stated before this, but for the second point, I just want to ask, okay, What is the difference between definite and indefinite integrals? Anyone? Definite and indefinite.
Indefinite, no limit. Definite, ada limit.
All right. Thanks, Mila. Okay. Now, we recall back from the definition of an antiderivative that, okay, when we differentiate fx, we got gx. Okay. Then same goes to when we integrate gx, we can get back the fx plus c. Don't forget this. Okay. Okay. Now, we will see the list of table. Okay. Every time we have differentiation formula, okay, we get an integration formula for nothing. Okay, now let's look at derivative rule. Okay, when we differentiate sine x, we got what?
Cos X.
Okay, and then same goes to anti-derivative rule, where we integrate cos x, we can get sine x plus c. Okay, now wait. Okay, and same goes to when we differentiate cos x, we can get negative sine x. Okay, this is just the inverse of the functions. Okay. Okay. So now we know the previous trigonometric functions. Okay. These tables. Okay. Is we got integral rule and also general rule. Okay. Um, it's just the same like the previous one. We learned about derivative and also antiderivative rule. Okay. So far, has everyone not understand anything about the rule before we move to the next example?
No.
Okay. And so, okay. But I just want to highlight this. Um, don't forget when we integrate secant x, tangent x, or cotangent x. Okay. Don't forget to include ln. Okay. Ln, like example, when we integrate secant ax, we can get 1 over a ln secant ax plus tangent ax plus c. Okay. Now, I just want to ask a quick question. Okay. When we integrate tangent x dx, okay, what can we call this this form? Sine x over cos x. What kind of identity is this? Anyone knows? Like Razor? Question, identity. Good. Okay. Now we move on to next example. Okay. Which is the indefinite integral. Okay. From the properties of indefinite integral. Okay. Do you guys still remember the rule that teacher Riza mentioned before? Which which rule is this? May I know, everyone?
Rule number 2. Second rule.
Okay. All right. So when we integrate this 5 cos x dx, okay, just do like the usual, then we can get 5 sin x plus c. Okay. For second example is a little bit different because we're gonna use substitution method to solve this. Okay. So do you guys still remember about substitution method? Okay. Now this is just usual technique we use. Okay. I just want to ask back why we want to get dx instead of just let this the final form when we want to differentiate. Why we want dx of, equals to 1 over 2 du? Does anyone knows?
Easy to substitute.
You can see the answer here. Alright, yeah, we need to substitute the dx, okay? This one, okay. And then we just substitute like usual, and we can get the properties of integral, and you can solve the question, and you can get this answer. Okay. Until now, does everyone not understand anything from the previous example? I'm not mad at everyone. Okay. Okay. So I guess that's all my teaching lesson. Okay. Now we move to another example going to be presented by teacher Farah.
So good morning, students. So with me here today with teacher Farah. After this, we're going to go through all the examples 3, 4, and 5. And then after that, we go through all the limits of integral. And then teacher Marina will be controlling the slide since I have a technical issues. Are you okay with it?
Okay, yes.
Yes.
Okay, very good. Since you are in very good condition, I want all of you to participate. All the questions that I'm going to ask will be answered of you, okay?
Okay.
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 Let's see example 3. Integrate secant square x dx. I want to ask how many functions do we have here?
1.
Very good. Since we have one function, it will go very simple. If we integrate secant square x, we will have 1 over,
Cos.
very good, 1 over cos square x dx. Don't forget the dx, okay? Okay, after we integrate into the simple form, then we have to let u is equal to tangent x. So I'm going to explain why we have to integrate it become tangent x. Because there is relation between, after we integrate tangent x, we will have sin x over cos x, right? So there is a relation between 1 over cos square x and sin x over cos x. You get me?
Yes.
Okay. So sin x over cos x. What rules will you use?
Question rule.
Very good. Why we have to use quotient rule? What are the characteristics of quotient rule?
Division.
Very good. And then the next one?
Two function.
Very good. Two functions. First one division, and the second one we have two functions. That's why we have to use the quotient rule. And then vu prime minus uv prime over v squared. That is, you have learned from the previous chapter 3, differentiation, right? And then we go through. We have the answer we have on the step 2 is cos square x plus sin square x. But if we see the step 3, we have 1. Why do we have the answer 1? I'm going to ask why cos square x plus sin square x is equal to 1. What identity we use here?
Trigo identity.
Yes, very good, Amila. We use identity. That's why it's explained is equal to 1. And then we have 1 over cos square x is equal to secant square x, right? And then from the previously, what integrate 1 over secant square, we have 1 over cos square x. And then if we integrate u, we will have u. So since here u is equal to tangent x, this is explains that y integrate secant square x is equal to tangent x plus c. Okay? You okay?
Okay.
Alright, so let's go through example 4. Okay, for example 4, integrate x secant square x to x dx. How many functions do we have here?
2
Yeah, 2. What is the first function?
x
And the second function?
secant squared to x.
Yeah, secant square dx. So if we have 2 functions in integration, we have to use integration by part formula. Okay? Let's see here. There is integrate u dv is equal to uv minus integration of v du. Alright? We integrate x and we have dx. And then if we integrate secant square to x, we get 1 over 2 tangent to x. From the previously, Teacher Marina and Teacher Rizal have shown you a table and all the simple rule, general rule, integral rule. This is what explaining all how you get the answer. Then you have to cross uv and then integrate dv du, and then you have the 1 over 2 into the equation below. Do you have any questions so far?
No.
No.
Alright, then after that you see here, please note that integrate tangent theta d theta is equal to ln secant theta, right? Okay, here we have to use the this formula is given in the previously table, right? So here there's no explanation for there. And then this is the final answer, 1 over 2x tangent to x minus 1 over 4 ln secant square x plus c. Okay, what's important here is after integrate, you have to plus c. If you integrate but you didn't plus any c, you didn't have any mark, right? Okay, next. Okay, example 5. For this example, I want to call upon one of you to explain how you get the answer. I would like to call upon Muhammad Hazim to explain to all of your friends how did you get this answer. Muhammad Hazim, are you there?
Yes, teacher.
Okay, can you explain how you get this answer? What is the first step you do?
The first step that we do is change the form
Yes,
of
what
the
form?
trigono to cosec change to 1 over sine,
Very
and for
good. Next.
tangent x change to cos x over sin x.
Very good. Okay. Then?
And then that is after that we multiply both that,
Yeah.
and then we get cos x over sin square x.
Very good. And then?
Okay, and then we should let u cos x dx.
Okay.
Okay, so then we'll get the integral 1 over u
Yeah.
square.
Very good. Okay. So ask your friend, do they understand? Do they have any question?
Do you guys have any question?
No.
You got it? All right. Very good. It means you clear. You explained very clear, Hazim. Very good. Excellent. All right. Okay. Let's go to next slide. Very good. Good job.
Next.
Okay. So this slide is about the limit definition of definite integral. So here you have seen the notation, which is integrate a to v, right? Okay, let f be a function which is continuous on the closed interval a to v. And defined as limit and approaching to infinity as sum of the product. Okay, here I'm going to ask A to B. Which value have to be the highest, A or B?
B.
B.
Yes, very good. B have to be the higher value than A, because if you see the formula here, B minus A over N, right? And basically, this formula is to calculate sum of the areas. Since it mentioned the area must have to be in a positive value. If not in a positive value, then your answer is wrong because it's in area. Get me?
Yes, teacher.
Alright, let's see the example to make things very clear. Next slide. Okay, let's see here. Integrate x sine x dx from pi over 3 to pi over 2. So what is A here and what is B here? Amelia.
A pi over 3, B pi over 2.
Okay, very good. So Adavia, how many functions do we have here?
Oh,
Very good. Nisa, what is the function number 1?
X.
The function number 2?
Sine X. Dx.
So what formula do we use?
I found.
Yeah, very good. By part, right? So by part. And just like previously, let u is equal to x, and then we differentiate u, and in differentiate x, we become dx. And then we have dv sine x, differentiate v, if we get negative cos x. Just like simple, right? Just use the formula, and then we have, alright, then we have the answer. Then we just substitute the a value and the b value in the x, right, in the coefficient. Make sure b minus with a. Okay? Are you clear? At this step, do you have any question?
No, teacher.
No.
Okay. And then, alright, very good. So, okay, I want to inform in the final answer, since you substitute all the x, at the end you have to get a complex number, a value, a rigid value, like no coefficient, no x, no any coefficient you don't have, and the answer must in a positive, because if we calculate since n b to a, it is an area. So an area I mentioned earlier, it's not in negative form, it must be in a positive form. Okay.
Okay.
All right, let's see example, next example. Example 7. So here is very simple, right? Just like how I mentioned earlier. You substitute it all, integrate it first, then you substitute all the value a and b. Make sure b minus a, all right? Okay. Okay. So I guess this is the end of my lesson, the end of my teaching lessons. I hope you're clear with it. If you have any questions, you can ask at the end of our video learning, okay? Then we continue with teacher Izzah.
You guys still here?
Yes.
Yeah.
Yes, teacher.
Alright, so earlier in our lesson, you have revised with Sir Rizal about the basic integration rules. And then just now you have learned about integration of trigonometric function. So to see if you guys really understand the properties well, let's do some exercise with me. Okay, let me open the media first. Alright, so school is finished and then we have to bring the kids home. Okay, so the rules is simple. You guys have to bring these children home, but before they can enter their houses, you guys have to help these children to answer the question that they have learned in school. So let's start. You guys can choose any of the children.
I want to choose the green boy.
Alright, good Azim. Okay, so let's see. Alright, so here's the question. We have integrate negative x cosecant square 5x dx. So what is the first step to solve this problem?
Factor out the coefficient.
Which coefficient?
-8.
Alright, very good. Okay, so we put out this negative 8 outside of the integral sign, and then we will have integrate cosecant square 5x. So we can directly integrate and then we will get the answer. So I want you guys to answer this first and I want to see your working step and we will discuss later. Alright, time's up. Have you done?
Yes.
Did you get the answer? So anyone? Any of you wants to volunteer? Alright, good Mila. Okay, you can show me your answer. Let me pin you to screen. To the left. Okay. Alright. Okay, so you get 8 cot 5x plus c. Alright, let's see if your answer is correct. Alright, so here is your answer, right, Mila? Okay, let's see. Oh no, so you're wrong. It's okay. So let's see. Which one is the answer? Any of you wants to help your friend?
Me, teacher.
Okay, Adawia, show me your working step. Okay, wait a minute, I couldn't see it clearly. Alright, okay. So you get 8 over 5 tangent of x plus c. Okay, so do you want to explain? Do you mind to explain to your friends, Adawia? Okay, let's see here. Alright, let's select the answer first. Okay, so Adawia choose the circle, the blue circle, right?
Yes.
Alright, so okay, very good, Adawia. So here is the working step. I want you to explain to your friends. How did you get this answer?
We
Alright. Okay, first we take out the
put
negative.
multiple outside.
Alright, okay.
Second, I integrate the cosecant square into
Right.
negative cot plus c,
Okay.
and then I multiply negative 8 with negative 1 over 5,
Yeah.
and then the cot
change into 1 over tangent
Okay. So why are you doing that?
using reciprocal identity.
Okay, very good. So you expand and then
And
you will.
then I get
Alright, very good, Adavia. So here is the answer. Do you understand, Mila? Mila, are you okay? Alright, okay. So don't forget about the coefficient here. Here 5x. So that's why you will get 8 over 5 instead of the instead of 8 cotangent 5x plus c, you will get 8 over 5 cotangent 5x. So here I repeat, you have to write down cotangent 5x equal to 1 over tangent 5x according to the reciprocal identity, because tangent x equal to 1 over cotangent x. So if we rearrange, we will get cotangent equal to 1 over tangent x. Okay, so here is another solution you can use to solve the problems. So let's continue to our next question. Okay, choose the next key.
I want to choose the purple girl.
Okay, very good, Lisa. Alright, okay, let's see. Okay, so here's the question. The first question doesn't have, the first question is indefinite integral, but this one is in definite integral because they have what?
Limit.
Yes, very good. It has a limit, so that's why it is called a definite integral. So now, what is the first step?
Put 1 over 3 outside.
Okay, very good. Put 1 over 3 outside, and then we will be left with sine x inside the integral, right?
Yes.
Okay, so I want you to integrate the sine x and then substitute the upper and the lower limit to get the answer. Alright, have you done? Maybe Nisa, you want to show your working step? Alright, so you get, alright, okay, okay, lower, okay, lower, okay, alright, negative 1 over 3 equals to 5 minus, alright, okay, so you get negative 1 over 6. Alright, thank you, very good, Nisa. Hazim, what did you get?
I get the same answer
You
as
get the same
Nisa.
answer.
Yes.
Alright, okay. Okay, so let's see. So you guys get negative 1 over 6 for the answer, right?
Yes.
Okay, so we'll see if it's correct. Okay, very good. So I assume you guys have no problems finishing this, solving this question. So here I'll just briefly explain to you guys. We take out the 1 over 3 outside of the integral sign, and then I wanna point this out. Once you integrate sine x into into negative cos x, you cannot write down this integral form anymore. but you have to write it down in the form of bracket. And then the upper limit will be in the above, and then the lower limit will be written in the lower part. So I want to ask you, what is wrong with this step? Okay, Amila, maybe you want to answer my question? What is wrong with this step? It is missing one important thing here. What is wrong with this step? Alright, it's okay. So it is missing a plus C here, right? Isn't it?
Yes, teacher.
Yes, very good. So don't forget the plus C. You have to write down the plus C here because you haven't substituted the upper and the lower limit yet. So it must have the plus C because you integrate sin x, you will get negative cos x plus C. So then after you substitute the upper and the lower limit here, you don't have to write down the C anymore. So the final answer is negative 1/6. So like teacher Farah have taught before, the upper limit will minus the function substituted with lower limit. Alright? Do you understand? Everyone, are you guys okay?
Okay, yes.
Alright, good. Okay, let's continue to next question. Okay, choose another kid. A program. Alright, okay. Okay. So here is the question. So I want to ask you how many functions here?
Two
Two
function.
function.
So how do you want to solve this problem? Before this, in the induction set, you have revised with Sir Rizal, right? If there is fx plus minus gx function, you have to integrate.
Correctly.
Yes, very good. So here you have to integrate to x, and then you have to integrate cos to x. You can directly integrate, never mind, but you can also write down the integral sign to see more clearly. So what is, if you integrate sine to x minus cos to x, what will you get?
Negative 1/2 cos to x.
And if you integrate cos to x, we will get
1/2
Negative 1/2 sin.
sin to x.
right. Okay. All right. Very good. So negative, we will get this, including this negative. So we will get negative 1/2 cos to x. Sine to x. I'm sorry. So if you substitute the upper and the lower limit, what will you get? You can solve it first. Okay. Let's see. Anyone wants to volunteer? Adawia, have you done?
Yes.
Okay. Let show me your answer. What did you
Negative
get?
1.
Okay, you get negative 1. How about Hazim?
I got negative 1 too.
Alright. Okay. So Nisa, are you okay? You get the same answer as your friends?
Yes.
Alright. Amila, are you okay? Have you done? Are you done? Okay. So what did you get, Amila? Alright. So let's see. Everyone get negative 1, right? Okay. Okay, so very good everyone. So this is the answer. You integrate sine to x minus cos to x, we will get negative 1 over 2 cos to x minus 1 over 2 sine to x. And since the question is integral, definite integral, so you have to write it down, the upper and the lower limit, and then plus c, the constant. And then we substitute x with the upper and then the lower limit, and we will get negative 1 of that negative 1 as the final answer. So very good everyone. So let's go to our last question for the last boy. Okay, so here's the question. So I want to ask you guys, what is the method that we can use to solve this question? What is it? Who answered the question? Okay, Amila, good question. Okay, another method.
Substitution.
Yes, very good, Hazim. So we are using a use substitution. Okay, so I want you guys to solve this question first. Okay, time's up. Did you get the answer?
Yes, I got the answer, teacher.
Okay, very good. Can you show me your answer? Wait a minute. Okay. All right, very good. Yes. All right, okay, very good. Azim, thank you so much. Okay, so let's discuss it together. So here, you answer this one, right?
Yes.
Yes.
Okay, very good, everyone. So here is the question. And then we take out the cos 5x here and put it here, leaving a 1 over 3 plus sine 5x. And then we let u equal to the denominator, 3 plus sine 5x. And then we differentiate u, we will get 5 cos 5x. And why did we let cos 5x the x equal to 1 over 5 du? Everyone?
Because we want to substitute.
Yes, very good. We want to substitute. So here is cos 5x dx. And then we have let this 1 over 3 plus sine x equal to u. So it will become 1 over u. And so we have to make sure that dx is also in terms of du. We get this step, and then we put out the 1 over 5 outside like before. And then when we integrate 1 over u, what did we get?
Lon
Lon
U.
U.
Very good. We will get ln u. Substitute back the 3 plus sine 5x here, and then when you expand, you will get here is the final answer, ln 3 plus sine 5x over 5 plus c. So let's see your understanding regarding this topic, and Sir Rizal will conduct the assessment.
Okay, so you guys, hi, still okay? Because we are
Yes.
going to continue with the assessment, I want to test your knowledge about this topic, today's topic lessons. Okay, do you see? Next slide. So I have prepared questions regarding our topic today through Kahoot website. So I want all of you to access Kahoot right now, because I will give you the Kahoot ID, and I want all of you participate in this kind of game to answer all the 4 questions that I have been prepared. So I give a time for you to access the Kahoot right now, and I will share you the ID through this screen. Do you guys see on the screen?
Yes.
Anyone can respond? Yes.
Yes.
So I will start to share the ID right now. So here's, wait, okay. This is the ID, so you can access by your laptop or phone that you have used right now. So make sure you use your own name so easily. I want to know who is it. Hazim, okay, Hazim already entered. So Nisa, okay. I just changed the song. There we are. Okay, all the 4 players is here. Okay, are you guys ready? Okay, so I will click
Yes.
start right now. So evaluate the integral. So here the question, integrate cos 5x dx. So what is supposedly the answer we will get? Okay, 1 already answered, 2 already. Okay, there's another 2. The clue is you have to use the U substitutions. Okay, I give you a clue if you don't have any idea. So 1 left. So let's see who got this right. Another 1 left. Okay, take your time. You have about 50 seconds left. About 2 seconds left. Okay, so congratulations to the 3 people that got it right, and it's okay for the that got the wrong. So who got? Okay, so Adavia is in the first place, Amila second, Hazim third, and Nisa in the 4th place. It's okay. You can change your position in the next question. So do your work well, and yeah, memorize back the rules. Okay, so the question, the second question is integrate second x. So actually this is simple because teacher Marina already told about the rules, so you can directly integrate it and you just get the answer directly. Doesn't have any kind of substitution or what. You can remember back the slide or what. You have your note. 50 seconds left and there's nobody answer it yet. And of course, the answer will be have blonde there, because yeah, the optional answer is also have blonde. So there's 1 people already answer it. The song is like trigger you, right? You have about 20 seconds left. Okay, there's 1 more. Okay, congrats to 3 people also, and just 1 that did not get the answer. Who's that? So Adabia is still in the first place, and Hazim already second, Amila third, and Nisa in the 4th. So congrats to you, but we have like 2 more questions. So just do your best and don't make a mistake, okay? So this is what kind of form? This is a definite integral. So because you have a limit there, and you have to integrate it. the sin square x dx. So just remember back what teacher Iza already taught, teacher Farah, teacher Mar, okay? So you have about 16 seconds left. I just give a clue. If you don't have any, you just to use the common identity, okay? And then you have to take out the constant by using the rules, which is the KFX, okay? And then you have to use the sum rule also. So that is the just I give a clue, step by step. Okay, there's two answers. Can I see the people here? Okay, they're like focused. It's about 10 seconds left, and there's like 2 people did not answer yet. Better you make a decision. Which one? 6, 5, 4, 3, 2, 1. Faster. So just one only got it right. So there's 3 people got it wrong. So who's the one that? Oh, Nisa got it right, and we are still in the first place. So Nisa in the second place. Congrats to you, Nisa, and Hazim the third, and Amila the fourth. So let's see who's going to challenge Adavia in the last questions. Whether there's like changes in the position. So this is the definite integral also. 4, where the limit have a 4 and 1, cos x minus 3 over x to the power of 5 dx. So you just have to use the same kind of method in this because it's minus. We have 2 functions there. So I give a clue. You have to use the sum rule, which is the fx gx. Integrate both functions. We have about 50 seconds left. Let's see the last question who got it right. It is already like 30 seconds left, and there's no one answering yet, so maybe it's quite difficult, I guess. 25 seconds left. So about 20 seconds left, and there's no one answer yet. Faster, right? You have to choose it right now. Make a decision. In about 10 seconds, 9, 8, 7, 6, 5, 4, 3, 2, 1. So there's like 1 people doesn't answer it, I guess. So there's 1 people got it right. So who is it actually? So let's see the podium. The third one, Nisa. Congratulations, Nisa. And the second one is Adawiyah. Oh, Adawiyah is second. So the first one is going to be Hazim. So congratulations to 3 of you, and for Mila, I also congratulate because you participate in this kind of game. I really appreciate it to all of you because you're already doing your hard work in solving this question. So right now, I open chance for you to ask me which one of questions that you want me to ask to discuss with you. So any question that you want me to discuss it? Yes, can I discuss the last one? Because since like there's 1 people get a chance to answer it. So this is the last questions. Wait, okay, this is right. So we have the definite integral of this question. So we have integrate 4 with and 1 cos x minus 3 over x to the power of 5 dx. So in this kind, I already say that we have to apply the sum rule or the basic rule of integration, which is here, the basic rule, and you will get this in this form, isn't it? So you have to integrate cos x and integrate also 3 over x to the power of 5. After you integrate both functions, you will get this, okay? If you integrate cos, you will get sin 4 minus sin 1, and if you integrate 3 over negative s5, yes, you will get 765 over 1024. After you integrate both functions, you just have to substitute back in the form of the questions, and you just get the answer. And don't forget about the plus C here, because it is the integral form. So you have to put the constant term because we didn't know the specific constant value there. So yeah, this is the form and this is the solution. So do you have any questions? Any questions regarding the Kahoot questions? Which part that you didn't have? Did you have a problem or what? If not, you can just say no, so I can proceed.
No.
No. So you guys okay? And I just want to congratulate again to all of you because you have did a good job, and it's nice to play with the game with you. And yeah, I think that's all for the assessment. And I will give back to Teacher IZZAH to conclude back what we have learned in today's session. So have a nice day, everyone.
Alright, so very good everyone. So before we end our class today, I want to refresh back what you guys have learned today. So I want you to take out one piece of paper because we are going to do a 2 minutes paper. And I want you to write down 3 main points that you have learned today. Start with the definition of integration, and second, the method that we have used in this lesson, and then the third one is the properties. So we have 9 properties. So I want Nisa write down first 3 properties, and then Adawiyah the next 2 properties, Hazim next 2 properties, and Amila the last 2 properties. You get me?
Yes,
Yes.
teacher.
Okay, very good. So I'm giving you guys 2 minutes for the 2 minutes paper. Okay, let's start now. Okay, time's up. I want you to simultaneously show me your 2 minutes paper. Can you guys? Okay. Alright, very good, Hazim. Oh, okay, very good. And then Adawiyah, let me see. Okay, good. How about Nisa and Amila? Alright, very good, Mila. Let's see the last one, Nisa. Okay, very good, Nisa. Nisa, I think you have mistakenly write down the basic integration rules. I'm telling you guys to write down the properties of integration of trigonometric function. It's okay. So let's discuss together. So we have what is the definition of integration? What is the concept?
Antiderivative.
Anti-derivative.
Derivative.
Okay, very good. Derivative. And then what is the method that we use to solve integration?
Substitution.
Very good, Amina.
By part.
What? Okay, very good. Nisa.
Integration by part.
Okay, very good, Aziz. Okay, so we have for the properties of integration of trigonometric function, create sine x, you will get negative.
Cos x.
Very good. And then when we integrate secant square x, we will get.
Tangent x.
Tangent x.
Okay, very good. Okay, so if we integrate function with the coefficient, for example, cos x, we will get what?
Sin x plus c.
Not correct. We have a coefficient. So what will happen to the coefficient?
1 over a sin ax plus c.
Okay, very good, Amila. That's all for today. Thank you.
Thank you, teacher.
Thank you, teacher.
Alright.